This is Sprint 4 review for Team GVR-BOT. Team GVR-BOT includes Cadets Tan, Cadet Bansky, Cadet Moffat, Cadet Vosberg, and Cadet Uehara. Our instructors are Major Dominic M. Larkin and Lieutenant Colonel Christopher Lawrence.
This is our product roadmap for Sprint 4, 5, and 6. In Sprint 4, our goal was to implement a web app with existing data, create a GUI interface for the GVR-BOT, establish mobile testing framework for all GVR-BOTs. Our major feature additions include data from test plans in CSV file, saved in database, and a GUI interface. The architecture we upgraded includes a mobile test platform and the fabrication for all GVR-BOTs. Communication events during this sprint are the Sprint 4 review and CDR2. And finally, the release goal for this sprint would begin mobile testing.
Our Sprint 4 goal is to design and implement a mobile GVR-BOT platform and system to conduct tests for speed, load, and battery state to load to a database. Challenges for this sprint were limited testing ability due to platform troubleshooting and database errors. For Sprint 4, we had 32 individual tasks with an assigned 165 hours and an actual completion of 190 hours. We completed more hours than assigned due to unplanned events such as making the GVR-BOT compatible with the fidgets and research loading ROS into the Raspberry Pi. We were not able to complete all of our test trials, which is why our estimated hours is at 208.
This is our burn down chart for Sprint 4. Currently, there are 69 hours remaining. As of last night, February 14th, we have completed 187 hours. This sprint lasted from the beginning of January until the mid of February. Please notice the general linear fashion of our hours completed.
Here we have our individual tasks. It's broken down by the team member as well as the primary, secondary, supplementary, and additional tasks completed by those team members. Please note that the color of each block corresponds to the subtask for the sprint.
The GVR-BOT GUI we created is called Mission Commander and is currently at version 1.2.0. The screen on the left shows a basic controller for the GVR-BOT that allows a user to move the robot forward, left, right, and backward, increase and decrease power, and use flipper control. The screen on the right allows a user to select specific missions or desk testing. Each screen shows a basic battery information and motor power. Using a model view controller method, we created multiple files to interact with each other to allow a user to interact with a model and view to control the robot through specific automated commands. With information from ROS topic echo and the SM bus, information from GVR-BOT while it's moving is presented to the screen, allowing the user to better control the robot. This video demonstrates the GUI commander working for a desk test. After the user clicks the launch file on the desktop, the commander will be brought up to the screen. In the file toolbar, a user can connect to the Wi-Fi of the GVR-BOT. After it's connected, they can go between square routes, linear routes, and the mission commander to choose the current route. On this test, we will use a desk test in normal settings. Once the command is clicked, the robot will run until it's told to stop. The current speed is linear at 1. On the other computer, we can use the SM bus parser to collect information about the robot. Here's an example of the computer logging information during a desk test. This video demonstrates our GUI commander controlling the mobile test apparatus during a linear test. While this video is sped up to 4 times speed, you can see the robot moving autonomously during a very simple route. Additionally, a user can select a square route to move the robot in a square continuously until it's told to stop. At 4 times speed, you can see the robot moving forward, turning right, and moving forward in a perfect square. Besides pre-planned routes, we have the capability of running multiple desk tests at the same time while collecting data on both robots.
Here is a demonstration of the parser scripts. First, you will need to log into the Raspberry Pi remotely using SSH. From there, we log into the Raspberry Pi using the login credential Pi and Raspberry. We will then change directories to all the way to the parser folder, which is either the DATAC folder or the SMBus folder. We will then need to run the program using the Python command, and which is latest stable version of either parser. Enter in your table name and it will start parsing the data. It is the same steps with either parser. With a DATAC parser, however, the tester will need to enter the device name and location. Here it is running.
This is the mobile test platform currently used for the GVR-BOT. This is the battery connector that is BB2590 connecting to the PCB. This is the area of the robot that contains the printed circuit board and the Raspberry Pi, which is stacked below. The PCB is broken into separating the SMBus data from the power supply. The blue box is the SMBus data, whereas the red box is the breakout for the power supply of the robot. The power supply is connected to the robot's side port over the treads. This is a zoomed in of the Raspberry Pi below the PCB. The blue box is where the Raspberry Pi reads the SMBus data. The red box is where the Raspberry Pi connects to the USB ports, which is connected to the DATAC. And the yellow box is the regulated power supply from the buck converter. This is the DATAC model DI-155 used for reading data of the power supply of the battery. The DATAC reads the voltages of each cell of the battery as designated by the yellow squares. The red square designates where the DATAC records the current drawn from the battery. It does this by reading the voltage across a shunt resistor connecting the grounds of each cell of the PCB. This is the buck converter used to power the Raspberry Pi. It connects to the robot's port and is capable of regulating from 3 to 40 voltage to a steady 5.1 volt.
Here's the block diagram for the hardware setup of our project. The only major changes are that the Raspberry Pi is being powered off of the robot, and there is an addition of a second antenna. Here you see a diagram of the PCB that we've created. The dashed lines represent the binding posts where we connect the power, and the lower labeled block is the SMBus. The circuit on the right side is a thermistor and is not implemented yet.
These are the tracked variables for our speed test. We will go over the major variables in the following slides. This is the voltage for our high-speed speed test. This is the voltage for our medium speed test. This is the state of charge for our high-speed speed test taken from the SMBus. This is the state of charge for our medium speed test taken from the SMBus.
Here is a reflection for Sprint 4. Here are the reasons why we did not meet our sprint goal: troubleshooting data logging platform and the increased requirements for software as well as hardware from the product owner. We have updated the product roadmap moving into Sprint 5. Current state of completion is as follows. To reiterate, here is our product roadmap going into Sprint 5. The only major change would be moving testing from Sprint 4 into Sprint 5.
This concludes our Sprint 4 presentation. We will now take questions and feedback.